Welcome to this video. In this video, we are going to solve one of the recent LLD question that was asked in Flipkart machine coding round. So the question name is FoodKart LLD. Let's move to the problem statement. So we need to implement the simplified food orders management system named FoodKart. So when we hear about food order management system, what comes into our mind? There are few popular food order management systems that are available in the market. Those are like Zomato and Swiggy. So this problem statement or this machine coding round involves designing a system that simulates food ordering from restaurant with in-memory data structures. That means we do not need to use any external database during our system design code execution. The challenge that is going to be tested during this round is object-oriented design, modularity, clean coding, and extensibility. So let's try to understand how much time we are going to get during this round. So this round is going to be a round of 120 minutes, out of which first 30 minutes will be taken care by the interviewer to explain the problem statement, the features that we need to implement, and the input output, how we need to take input in the system, and which kind of output they are expecting. During this discussion, candidate can also clarify the requirements and try to understand more on the features part. So remaining 90 minutes will be given to implement the or code the problem statement and try to get the desired output by keeping in mind to follow these design principles. So move to let's move to the key features that we need to implement. Onboard new restaurant with menu and processing capacity. So our system should able to onboard new restaurants with menu items and processing capacity. Update restaurant menu prices dynamically. Each restaurant we should able to update the menu and its prices dynamically. Place order based on restaurant selection strategy. So when we will code our solution and discuss about it, we need to define a restaurant selection strategies. There are going to be different kind of selection strategies that we can use, but we also need to keep in mind what is asked in this particular interview question. Based on that, we need to define a selection strategy and need to use it. Let's move to the other point. Order must only be accepted if all items are available and capacity allows. So when we say if all items are available, so where these items needs to be available? These items needs to be available in a particular restaurant that we are selecting through a restaurant selection strategy. And the capacity also, this capacity allows. What does this mean? Each restaurant has a particular processing capacity that also needs to be fulfilled by a restaurant selection strategy. Then we need to dispatch orders, making room for new ones. Keep tracks of items served per restaurant. So each restaurant, how many items it is serving, how many total items that this particular restaurant has served. We need to keep track of this as well. Process a set of commands sorted by timestamp. So how we are going to take inputs and our system entry point will have input statements that will be processed in a sorted manner using commands. So we will create a command executor. Class in our solution, and then there is a bonus question. If we are able to code out from 1 to 7 points during the 90 minutes, then we can after that we can start working on this as well. So I think now the features that we need to implement in the system are clear. Now let's move to there are input and output handling is also given, like we need to took commands as string with timestamp. So commands we need to take as input string. We need to parse and sort it based on the timestamp before processing. We need to pass the data in our command executor that we are going to create. That command executor will handle these kind of things. So now let's move to the dispatch confirmations, or what we can say, this is input. Let me change this to input input format. So how we are going to get a input format? So if you see carefully, each line has one command associated with it. Place order, update price, dispatch order. These are going to be various commands in the system that we need to provide. Then this is the timestamp we are talking about, that we need to sort as written here. Parse and sort based on the timestamp before processing. And then after that, there are the command fields that are required. So for placing order, we need to define the order ID and the items inside it. Now before moving to solution, we have identified while discussing the key features, there are going to be some entities. Let's try to discuss the entities that are going to be associated with it. Whenever we are solving an LLD problem, the first step that we need to identify the entities or objects that we are going to deal with. Then the second step is going to be relationship between those entities and how those are going to be interacting with each other. So let's see. I can see on the point number 1, when we need to onboard a restaurant. So restaurant is going to be a one entity. Processing capacity is going to be a one entity. No, processing capacity is not going to be a one entity, but a menu or menu item can be a one entity. So in this one line, we can identify there are going to be two entities, restaurant and menu item. Then in second line, update restaurant menu item prices dynamically. Here, there is no new entity that we are able to find. In third point, we see place orders. So order is going to be one new entity that we need to deal with on a restaurant selection strategy. So restaurant selection strategy is going to be an interface in our system, and there are going to be different selection strategies. It can be multiple. So restaurant selection strategy interface we need to implement. Order must be only accepted if all items are available. If we carefully read here, we do not find any more entity apart from order, dispatch order. So this is again order. We do not need to have more any new entity. Keep track of items served per restaurant. For this line, I think restaurant entity itself will have one list where we can keep track of items served or some kind of thing that we will look later. Process a set of commands. So for this, as we have already discussed, there is going to be command executor. So now let's move to the entities that we are going to define. So first entity, as I have already discussed, is going to be restaurant, that will have its ID, processing capacity, name, location or address. There is going to be one more thing that I missed here. Let me try to add. That is going to be list of menu items. If you see now, restaurant entity will have these many variables or parameters. Now let's move to the menu item. Menu item will have its name, ID, price is available, status. I think status and is available are kind of same thing. So what we can do is we can remove one of them. So now let's move to the order entity that will have order ID, restaurant ID, for which the order is going to get placed from, total numbers of items that we are going to place an order, total price, order status, and item list. So if you see, I have created a map of menu item and integer here. So what does this mean? Let's say a menu item has cold drink. An integer, one person can order one item in multiple counts. So we can order two cold drinks. So let's say price of one cold drink is rupees 50. So the total price of this particular item, cold drink, is going to be 50 into 2 is equals to 100. That this price 100 needs to be added or appended in the total price variable. I hope it makes sense. Now let's move to the order status. So this is going to be enum, that here we are going to use it. Every order has a order status. Let me, I think I have, every order has a order status, not the vice versa. So we can have different types of order status like accepted, rejected, dispatched, processed, that we will also see, or we can also define few more as per the requirement. Now now we have defined all the entities. So step 1, or the main step, the starting point is completed. Now we need to find relationship, or how we are going to create these entities. So for this, what we can do is we can use the different kind of services or controller. If you are aware about controllers service architecture, MVC pattern, where we have a controller, service, and then repository classes. So that strategy we are going to use here as well. Here we will not define services. Here we will not define the repository or controller layer, but we will have a service classes that are going to be processed via command executor. So for entity restaurant, we are going to have a restaurant service. What it will do? It will add or delete a restaurant. It will update restaurant menu items. It will update the processing capacity of each restaurant as well. And it will also provide the all the restaurants that are available in our system. I will come back to restaurant strategy after talking about the order service. Let's talk about order service. So what order service will do? It will place order, it will dispatch order, it will show the dispatch orders, and it will get a particular order, or we can say get all orders as well if we want. But I don't think this is asked in the problem statement, so we will not have it. So now let's move to the restaurant strategy. When we say restaurant strategy, when there is going to be one order, correct? So there are going to be different strategies that we can use, and our restaurant strategy will have one method that will be find restaurant. That will be giving us a restaurant. So what are the different strategies that are used in different kind of uh, food delivery systems, if you see lowest price strategy, nearest location strategy. But if we see the problem statement, order must be only accepted if all items are available and capacity allows. Here we are not checking based on the price and the location. In this system, we are not dealing with the location. So we need to design a strategy based on this question. I think that is going to be all items are available. That means and processing capacity is there. So these two things we need to check in a particular restaurant while searching, while selecting a particular restaurant for a particular order. So that's what I have defined here. Processing capacity. So this will search if a restaurant has the processing capacity and has all the items as part of order, because this is a requirement. If we select any restaurant based on the processing capacity, but it does not have all the items involved, then we will not able to proceed with that particular restaurant. We need to reject that. So these two conditions as part of this restaurant selection strategy, we need to check. First is processing capacity and all the items as part of order that should be present in a restaurant, then only that restaurant we can place that order. So now we have talked about order service. Command processor we need to define, that will have a method that will input the, that have a method process input commands. An input command, this will come as a string, or what we can say is list of string. Now let's try to move to the UML diagram. As we have seen different kind of services, different kind of entities involved. So I have already defined a UML diagram. I can go to, so this is the UML diagram that we are looking at. So if we see here, I have defined the restaurant. So it has the processing capacity, menu items, ID, address, name, and orders completed. So list of orders, if you see the data type, and menu items also I have defined as a string, a map that has a menu item. So what this string possess, this will have the name. So we can quickly search the menu item that we are looking for. We want to update based on the menu item name. So this will act as a key, menu item name. We can also define it as ID, but I have tried to taken it as name to make it simpler. Then we have a menu item object which will have its ID, name, price, and the is available. So if you see, restaurant and menu item will have some kind of relationship. One restaurant can have multiple menu items, and menu item will not, each restaurant will have a menu item. If menu item is not there, so there is some kind of association that we have defined. If restaurant is deleted, then menu item associated to that particular restaurant will also get deleted. Okay, so we have talked about restaurant and menu item. Now let's talk about order. So it will have its ID, status, restaurant name, This status is coming from a order status enum class that will have different kinds of orders. So it has ID, restaurant ID, restaurant name, item list. Item list, uh, it is a map of menu item and integer. So this integer will tell us the count if the same item is repeated and how many times. And total price will be calculated based on the item list provided. Then to maintain the orders, we will have order service simple. To maintain the restaurants, we will have restaurant service simple, restaurant service interface that will be implemented by restaurant service simple. Similarly, order service is implemented by order service simple. And order service simple, if you see, will have a restaurant service internally, because when we are going to create order, we need to assign a restaurant, correct? That will be taken care by the order service simple. We need to fetch a restaurant by using a restaurant strategy. So that's why it has restaurant strategy as well. So restaurant strategy is defined here, and we have defined in this, as we have discussed, there are going to be multiple restaurant strategies, but for our particular question, as per the feature that we need to implement, I have implemented a processing capacity restaurant strategy that is going to return a restaurant, and we need to pass the list of restaurant. So now we have gone, and then there is going to be a command processor that will interact with all the services. Command processor will have restaurant service, order service, how we are going to, and then these command processor will call these services and their methods to execute the particular command that is passed via input. So now let's try to move to. So now we have gone through the entities, different kind of services and their relations in the UML diagram. Now let's jump into code and see how we have coded it. So now let's me go through the restaurant class. Here we have defined the all the variables. Then we have a constructor, and then there are getter setter methods that are defined inside this class. After restaurant class, we will have a menu item class where we have defined ID, name, price, and is available flag. This also have its getter setter and the constructor. Then we have a order class. Order class has a restaurant ID. As we are not dealing with multiple restaurant, so we will inside a one order we will have one restaurant ID. Then order status, then all the item list that we are going to have inside an order, and total price. So we have defined the total getters and setters, and then as we are using order status, so order status enum is defined here. I have defined multiple few more order statuses, although I have not used it all in my implementation, so that's fine. Now we are covered with all the entities. Now let's see the restaurant service. Restaurant service will have add restaurant, update processing capacity of a particular restaurant, and get all restaurant. Similarly, we will have order service that will create and place order, dispatch order, show dispatch orders, and get order. Now let's see what does this FoodKart application has. So this is a main application where we are implementing, where we are creating all the objects, and then we are creating the command processor as well to execute the input commands. And here also I've taken the input as a string, as a list of string that we are going to pass inside the command processor. So let's see the command processor. So command processor has a restaurant service, an order service, and then there is one method, process input command, that will take the input commands, and then we need to parse it. So for each command we are storing it, and then I also created command with timestamp class that will have timestamp. For simplicity I've taken it as integer for now, as input, as in the input also it is given as integer, and then the command. So now let's get back to the command processor. Here we are able to add the commands array list. Then we are sorting the commands based on the timestamp provided, and this is important because this is already mentioned in the requirement that we need to sort and then execute. Then I created a switch case for solving each command that we are getting from the command array list, commands array list. As this is now sorted, so we will get the commands in a sorted order, and then we are going to fetch the parts. So this is just a simple logic to get the command type. Then we have command type. As I've already mentioned, there are going to be different cases based on that. Place order, update order, dispatch order, and then there is default case. So in place order, what we are going to do is we are fetching the order ID. As I have created the order ID as integer, so I need to remove the order from the input. If I go to the input class, we are getting place order like this, place order, order 2. So I am considering 2 as the ID and order as the just name of that order. So let me go back to command processor. Here we are getting the order ID, then we are fetching the items name. These are the item names. Then we are going to create order. So here we are going to call this create and place order. If we go inside its implementation, we are passing two parameters inside it, menu items and order ID. So if menu item is null, we can throw illegal argument exception. Then inside create and place order, we need to call the, as this is the order service simple, which has the restaurant strategy. So here we are calling the restaurant strategy and calling the find restaurant. So from the restaurant service, we will get all the restaurant and menu item list. So this menu item list will help us to find, to search in all these restaurants. If any restaurant has all these items, based on that we can search the restaurant. So let's deep dive inside this. If you see list of available restaurant, menu item list, and then we are just checking if it is null, then return null, and then we have created a variable selected restaurant. Maximum capacity will be of menu item list or dot size. So a particular restaurant should have at least maximum capacity of this. If it is less than that, then there is no point of selecting a particular restaurant. Then we will try to check all the restaurants, and first we will check the max capacity. If this condition holds true, then we will go inside this and assign the max capacity, and then we will check all the items that are present inside the menu item list. And we have created this flag. If this flag is true, then select restaurant will be the restaurant that is being first processed from this list. Here we will provide that. So if I go back to command processor, we are creating the placing the order. So now we got the restaurant. Now we will check all the menu items in this restaurant. We fetch the items from the restaurant, and then I have created logic for this. I will share the GitHub repo link also, so you can go in this logic. So what basically I'm doing here is for each item in the menu item list, I'm just checking if this item exists in menu item restaurant item list. Although this is already checked here, but I again checked it because this item list that is provided in the input is just item names, not the list. So that's why I need to fetch the restaurant uh, item list and need to search here, so that I can, while creating the order, I can set the item list, menu item list to be ordered. Set status. So here we are setting the order status as accepted. If we do not get any error during this execution, then we are calculating the total price. So here in the total price for each entity that we are going to get menu item list to be ordered, we are just getting the price of it and the value. So if there are going to be 2 cold drinks, then value will be 2 and the item price, let's say 50, then 50 into 200 will be added and sum will be calculated. Here we are setting the total price, and as we need to maintain the list of orders each restaurant has processed, that we need to, that's why we are adding into the restaurant entity. Restaurant service update processing capacity. uh, so as we are processing this particular order, we need to decrease the processing capacity of a particular restaurant. So we will get the processing capacity and we decrease it from the size of the menu item list. Then we will add it in the orders list that is provided in the order service simple, and then we will return the order. This is one flow that I have explained here. Similarly, we will have update price flow, where how we are using the restaurant service to update restaurant menu and price. Similarly, we will have dispatch order, and in this we are going to see get orders. We are fetching the order as, because we are getting the dispatch order ID, so we need to fetch the order first before setting its status as dispatched. If it is already dispatched, then it will not process this. It will throw, and it will print out this line and just break out of this condition. Then we are just dispatching the order. So this dispatch order will just set the, first it will check, and then it will set the status to orders status as dispatch. And here we are maintaining one more list, dispatch order list, that we can also use to fetch the dispatch order list if there is any new command, dispatch order list. So I think that's all in the video, and let's try to run this application. So I've created few restaurants, few menu items. If you see, I've created total 5 menu items, and each restaurant I have added. For first restaurant, I added item list. I created one menu item list, and then I added 4 of these menu items. And in second, also I have added 4 different 4 remaining menu items. Then we are adding the restaurant. Then restaurant, we are defining the restaurant strategy, because we have only defined one processing capacity restaurant strategy, so it is simple. Otherwise, we can pass it. Currently, we are directly passing the restaurant strategy. We can, if we want to define strategy based on some logic, then we can pass the values like command, select this strategy, and we can define inside the order service or command processor how we can select the restaurant strategy. But because we have currently one strategy, so I'm just directly passing it. And then there is list of commands. So let me try to execute this and let's see. So if you see, it is updated price. If you see the The timestamp of this is 2, that is lower than anything, so that's why worked it was executed in that order. Then we have placing order 1 with items paneer tikka. If you see after this will be get executed. Placing order 2 with items, there are 3 items, so order 2 is here. You see after 2 we are executing 3, then 5. Placing order 3 with items veg biryani and chole bhature, and then we are dispatching the order 2. So I think that's all from this video. I hope you like this video. Please find the Git link of this video in the video description. Thanks for watching this.